Namaste children, I am Hari Prasad, your chemistry teacher. Children, today we will start with the MCQ of the next chapter, that is chemical bonding. So we will go to the first question. The type of bonding present in the oxide of the element with atomic number 1. Children, which is the element that is having atomic number 1? Yes, you are right, it is hydrogen. Oxide of hydrogen is, I hope it is, right children, water. Now we all know that water is a what solvent? Polar solvent. So what type of bond present in this one? Right? So the type of bond present in this one is polar covalent. Do we have this option? Yes, we have here. So it is polar covalent. Right children? Is it clear? Okay children, let us proceed with the next question. The type of bond formed between two similar nonmetals. Similar what children? Nonmetals. Children, we all know that nonmetals are going to attain stability by mutual what children? Sharing of electrons. But when both the nonmetals are similar, like for example, it is H2, that is H and H, right? O2, O and O, Cl2, Cl and Cl. Then what is the type of bond? Now common sense says that in such kind of molecules, the shared pair of electrons will be exactly in the center, that is, it will be distributed equally. Then the type of bond present in this one is non-polar covalent bond. Do we have this option here? Yes, it is option A, non-polar covalent bond. Is it clear children? Okay children, let us proceed with the next question. The type of bond where the shared pair of electrons are distributed unequally. Now common sense says that why the shared pair of electrons are distributed unequally? See, for example, if we take HCl, right? Both are nonmetals. Now, when we compare hydrogen and chlorine, chlorine is more electronegative when compared to hydrogen. Because of that reason, the shared pair of electrons are closer towards which one? Chlorine. So this we say that electrons are distributed unequally. Now because the shared pair of electrons are closer towards chlorine, it will acquire a slight negative and this will acquire a slight positive. That is, positive pole and negative pole is developed. So this type of bond, we call it as what bond children? It is polar covalent bond. Do we have this option? Yes, it is option C. Is it clear children? Okay children, let us proceed with the next question. Element A has atomic number 17 and B has atomic number 12. The formula of the compound formed between A and B is, they have given 4 options. Now children, how to work out this? Children, as soon as you see the atomic number, immediately you have to write the electronic configuration. 17 means the electronic configuration is what children? 2, 8, 7, which is nothing but what children? Chlorine. Now 12 means electronic configuration is what children? 2, 8, 2. That is nothing but what children? Magnesium. Children, we all know that Mg is 2 plus, Cl is minus 1. When you cross the valencies, what you will get children? Obviously it is what children? MgCl2. That is nothing but, it is, Mg is nothing but B and Cl is nothing but A. So the answer for this one is Ba2. Do we have this option Ba2? Where we have this option? Yes, it is option C. Is it clear children? Okay children, let us proceed with the next question. Compound which conducts electricity only when dissolved in water. The options are sodium chloride, ammonium chloride, potassium chloride and HCl. Children, common sense says that sodium chloride, ammonium chloride and KCl are what children? Salts. That is, they all have a ionic what? Bond. That is, they are all ionic compounds. We all know that ionic compounds also conduct electricity in what state? Along with aqueous state, they also conduct electricity in molten state. So we are left out with HCl, which is nothing but a covalent compound which will conduct electricity only when dissolved in water. So the answer for this one is HCl. Is it clear children? Okay children, let us proceed with the next question. Compound containing 3 single covalent bonds. Single covalent bonds. For example, if you take N2. That is, between N and N, we have one triple bond. The next option what they have given is ammonia. That is, between N and H, one bond, N and H, one more bond, and N and H, one more bond. So it is 3 single. So let us check with oxygen. In case of oxygen, we have between O and O, we have one double bond. In case of H2O, we have 2 single bonds. So the correct answer for this one is which one, children? It is ammonia, the one which has 3 single covalent bonds. Is it clear, children? Okay, children, let us proceed with the next question. Compound having high melting point and boiling point has dash bond. Children, we all know that ionic compounds have a very high melting point and boiling point because between the ions we have a strong electrostatic force of attraction, whereas covalent compounds have a low melting point and boiling point because of weak van der Waals force. So the compound which has a high melting point and boiling point, that compound should be having a definitely what bond, children? Electrovalent bond. Do we have this option? Yes. The answer for this one is option C. Is it clear, children? Okay, children, let us proceed with the next question. The number of electrons present in the penultimate. Children, last shell we call it as what? Ultimate shell. Before last we call it as what, children? Penultimate shell. Okay, of an element with maximum IP in period 3. Children, we all know that across the period the ionization potential is going to what, children? Increases. So in period 3, the first element is what? Sodium, and the last element is what, children? Argon. So in penultimate shell of argon, how many electrons are there? So the electronic configuration of argon is 288. Valence shell has got 8. The penultimate shell also has what, children? 8. So the answer for this one is, do we have this option? Yes, it is option D. Is it clear, children? Okay, children, let us proceed with question number 9. The type of bond in compound formed between elements of period 3 and group 1. Okay, that element belongs to period 3, group 1, and one more element also belongs to the same period, but it is group what, children? 17. Now common sense says that group 1 period 3, which element is that? Sodium. Okay, group 17 period 3, which one is that? Chlorine. Now we all know that Na is a metal and Cl is a non-metal. Between a metal and a non-metal, the type of bond what you can expect is what, children? Yes, you are right. Ionic or electrovalent. Do we have that option here? Yes, it is option D. Is it clear, children? Okay, children, let us proceed with question number 10. During the formation of ionic compound, metals undergo dash reaction. They have given options: reduction, oxidation, redox, or none of this. Children, will take one small example. Formation of sodium chloride. Na electronic configuration is 281. Is it stable? No. When it will become stable? When it loses one electron that is present in the outermost shell. So Na will lose one electron to form what, children? Na plus. Now common sense says that who will accept this electron? The electron lost by Na is accepted by Cl. Why? Because the electronic configuration of Cl is 287. So after it gains that one electron, it will become Cl minus, whose electronic configuration is 288. Now in the formation of ionic compound, Na is losing electron, which is a metal. So loss of electron is called as what, children? Oxidation. Cl is gaining electron. Gain of electron is called as what, children? Reduction. Now metals will undergo what reaction, children? Yes, it is oxidation. Which option is right? It is option B. Is it clear, children? Okay, children, let us proceed with the next question. The type of bond in molecule containing most electronegative element. Children, which is the most electronegative element? We all know that it is fluorine. And element with one electron. Obviously, one electron. Which element is having one electron? It is what, children? Hydrogen. Children, we all know that when there is a tug of war game between these two, who will win? Fluorine. What I am trying to say is that when you compare hydrogen and fluorine, fluorine is more electronegative. That's why the shared pair of electrons are closer towards fluorine. That's why the fluorine atom will acquire a slight negative charge and this hydrogen will acquire a slight positive charge. So the type of bond formed between these two non-metals, it is polar covalent bond. Do we have this option? Yes, it is option B. Is it clear, children?